The concept of a tuned damper is not new. And what a tuned damper does is you take this mass and you tune it to a natural frequency. And that natural frequency is the frequency of a vibration you're trying to suppress. So if you have a structure that has a natural frequency that's shaking, then you can develop a tuned damper that's tuned to that fixed frequency. And the idea is it transfers the energy to the tuned damper device. So then the tuned damper vibrates at that natural frequency and reduces the vibration on the target structure. What makes this unique is the manner in which it performs. We can get an improved efficiency and an improved effectiveness for the same mass and the same size. The reason we developed this was necessity. What we had was a launch vehicle model. We were studying ground wind loads for the Ares 1X. And one of the most elusive things to understand about ground wind loads is a concept called vortex shedding, where you have a cylinder and you have flow coming around the cylinder, and it creates then a fluctuating lift that's nearly sinusoidal, meaning that the lift force shakes back and forth at a fixed frequency, where you can damage a launch vehicle, damage the payloads, or affect the guidance or navigation systems. And the Ares 1X was much skinnier than typical launch vehicles of that height. And when we were building this model for the wind tunnel, the damper systems were too fat in order to fit inside of this model to provide the effectiveness that we needed. Everything that we could find off the shelf in previous designs didn't work. And so we wanted a device where we can intentionally off-tune it and then tune it to various levels of effectiveness so that we can control how much damping was in that structure. So that's what this device does. It changed how much inherent structural damping a launch vehicle had to where it would slow down much faster. I think it has application to almost anything that's dynamic, a relatively fixed frequency, where you can't have a ground-based damper, which can be a helicopter, a grid-tied windmill. It can be a lot of different structures to where it's more cost-effective, like a skyscraper or many civil engineering structures. The biggest advantage is that you can achieve similar performance with something that's much smaller and much lighter. Or for the same size, you get substantially greater performance with this device. So if you own the license or if you own the patent for this particular device, then what you do is you have a competitive edge over the competition.
This NASA technology and many others are ready to be transferred to your business. Find out more by visiting technology.nasa.gov.